Today's show is sponsored by Spot by NetApp, providing a comprehensive suite of CloudOps tools that makes it easy to deliver continuously optimized and reliable infrastructure at the lowest possible cost. Imagine automating your infrastructure to proactively meet the needs of your applications. Imagine leveraging the latest in machine learning and automation to scale your infrastructure using the most efficient mix of instances and pricing models. Imagine running reliable applications, cutting cloud costs significantly, and making life easier for DevOps teams. From cloud cost management to infrastructure automation, Spot ensures you maximize your cloud investment. The end result is simply more cloud at less cost. Discover how the most innovative companies are automating, simplifying, and optimizing their cloud infrastructure with Spot by NetApp by going to spot.io/cloudcast to find more information, request a demo, or start a free trial today. That's spot.io/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And as I hit record on this, it is actually spring break here in North Carolina, and that means no school this week, and it also means both Brian and I are actually out with families this week, and I will be heading around to some colleges here in North Carolina with our youngest and doing some exploration and some investigation into potential futures and getting my youngest out of the nest, if you will. So really looking forward to exploring North Carolina this week. Let's jump in to Cloud News of the Week. First one is actually a short one, but it's worth noting for anybody who's followed VMware for any amount of time. Of course, they have their annual conferences in the fall, San Francisco or Las Vegas typically, VMworld, and then VMworld Europe as well, typically in Barcelona. I think one year we went to Copenhagen as well, but man, it's been VMworld for as long as I can remember. Well, it is VMworld no more. It is now VMware Explore. I guess as they are kind of making this shift to multi-cloud and moving away from some of the, the lower virtualization aspects of the technologies and kind of wanting to move up stack, they wanted to do a rebrand as well. Nothing more to report on that other than to kind of say as a, fan and have attended multiple VMworlds, it is kind of sad to see that name go away, but it is an interesting and logical move for them to rebrand as they move forward. For our next story, we have Grafana Labs. Grafana Labs announces a $240 million Series D round. And first of all, good for them. It was only 7 months since they did their C round. And I don't know if this is just a larger trend in the industry, and I may have talked about it once or twice on the podcast before, but as somebody who's done a number of startups, I also wonder, venture capital and going after these big rounds, and let's be honest, everyone's a unicorn these days. Being a unicorn isn't even that big of a deal anymore. But here's where I'm going with this. What does that do for the employees? Of course, the founders always make money on something like this. That's just the way these things work. But what about the employees? When they take these big rounds, what does that do to the dilution? What does that do to their diluted percentage of ownership with all of their shares and their options? And also the multipliers are just way out of whack now. For the one exit I did a couple years ago, we were like, I don't know, we exited at like 9 to 10x multiple. And things like that, just the numbers are way off now. So I don't know if it's worth something doing a whole dedicated show at some point on, but it almost seems like the math and the funding rounds has drastically changed here in the last couple of years, and the markets have changed. And I know we talked to Anil and some of the others recently about things like that, and maybe it's just a continuation of that trend. For our last cloud news of the week is actually Boeing. So Boeing announced a big contract to modernize and do a digital transformation. But instead of going with one cloud, they went with all the clouds: Amazon, Microsoft, and Google. So they went with the big three. Now, What I'm wondering about this and why we put this in this week is this another GovCloud? Did they do something like this because it is such a big contract, and if it's a big contract and it gets awarded to one and then they get sued because the others are mad? And again, is this a new trend that there is almost this invisible clip level where if you go beyond it, you almost have to give everyone a participant trophy, if you will. You have to give everyone a piece of that pie because if you don't, everyone will sue you. So is this almost the projects get so big that they become a liability for the companies at time? And that's an interesting trend we may want to look into at some point in the future as well. So that's going to wrap up Cloud News of the Week. Coming up right after the break, we have Ben Hagan, founder and CEO at Polyscale AI. He's going to talk to everyone about the challenges of database performance and how caching as a service can improve performance.
LoadForge provides load testing for modern web apps and APIs that's actually affordable. The platform can log in, maintain sessions, test any number of endpoints, and much more. Start with a browser recording or easily script your custom test in Python. Learn more at loadforge.com. Supply chain attacks and other application exploits are growing faster than ever. Lack of machine identity is a huge reason. That's why Teleport created Machine ID. Machine ID delivers identity-based access and audit for infrastructure resources like servers and databases, CI/CD automation, and microservices. By consolidating identity-based access for engineers and the applications they write, Teleport closes the identity loophole that enables compromised infrastructure and code to be used in cyber attacks. Download Teleport at goteleport.com/cloudcast.
And we're back. And folks, like a proud father, we sort of love all the shows. We love all the guests of the shows, but we always have a sweet spot in our heart. Kind of a thing for us that we love talking to new companies. We love talking about new technologies. It's always been really kind of the foundation of what we've done with the Cloudcast. And as you know, we've literally had hundreds of companies on the show, but we've been lucky. We've been able to access a lot of really interesting things, especially when they're new. And today's going to be one of those shows. So really excited today to sort of dive into a topic that I think a lot of you are going to be very interested in, because it's going to not only touch on delivering interesting cloud services. We're going to touch on accessing data, something that's potentially interesting for big applications, for edge applications. So really, really excited today to welcome Ben Hagan, who is founder and CEO at Polyscale AI. Ben, welcome to the show. Excited to have you on.
Thanks, Brian. Likewise, glad to be here.
As I look at your background, I look into your resume, you are very much a very data-centric person, right? The work you've done is super data-centric. Give us a little bit of your background, and then ultimately, what got you inspired to start, and found Polyscale, and ultimately also be the chief architect of what you're building.
Yeah, so absolutely right. So, all of my career, I think I've been involved in sort of data-driven companies or data-focused companies. And going back a few years, a startup I worked for called DataSift was really interesting in that they were ingesting kind of the world's social data. So just as the Twitter fire hose was coming into its element, and what we did there was we would ingest all of these data sources across news and social and things like Facebook and LinkedIn data. And the idea was to build an analytical application that was sort of privacy safe, that people could inspect how people were engaging with their brands. And what I was doing there was leading the a sales engineering team there. And what we would do is help customers ingest that data. And those data volumes could be pretty significant, thousands of sort of tweets per second, and then across multiple data sources. And so it was, how do we help customers ingest that data and start analyzing it and querying it? And a few interesting parts of that process sort of stuck with me over the years, which was, one was it was quite a hard thing. It was quite difficult to get that data to different parts of the world geographically, and into these disparate systems, be it a specific type of database or in those days it was sort of file systems or warehouses, but we're not going back too far here, sort of like 10 years. And it always struck me as to kind of how difficult that was. And it was always unique per customer. They had a different infrastructure, they had a different data layer, and they had different policies around retention, and it was all different. And then once that data was there, we started looking at query patterns. Some people wanted to actually run web applications on that data, and they needed fast access from multiple locations. Some companies wanted their data science and BI teams to access that data, and they may have different offices around the world where they were accessing that from. So there were these sort of underlying features of these polyglot systems and the transfer of that data and the sheer volumes of that data. And that was sort of the the beginning, or the underpinnings of inverted quotes, the sort of the big data era, and shifting large amounts of data around was kind of core to that. And from there, I sort of moved into working at specific database vendors themselves. I did a short stint for Elastic, who obviously known for their Elasticsearch product, and they were very focused on, there's lots of use cases that Elastic can be used for, but I saw these underlying issues there as well.
Yeah.
What happens when I need to scale Elastic to different continents and have highly available clusters running in multiple locations? And around the same sort of time there was a lot happening in two other industries that were really interesting. So inherently linked to Elastic was the APM industry. So being able to inspect my performance monitoring as a whole is critical. And people were putting direct dollar values against page load times. And that's really what sort of APM was pushing. We see that a lot in the e-commerce industry, whereby you can put direct dollar revenue amounts against how fast your page loads based on getting people through that sales cycle. So that was really interesting, and performance matters and has always mattered, and the APM industry was really sort of highlighting that. And then sort of going hand in hand with that and coupling with that was the CDN industry was really starting to demonstrate that serving stuff locally was good for everyone. And vendors like Cloudflare and Fastly and Akamai were sort of leading the way on serving stuff from local points of presence to customers, and just getting blisteringly good performance for that. Back then it was sort of that static data, images, movies, binaries, PDFs, things of that nature. So these topics have really stuck with me, and it's what we sort of see these things as now is it's kind of every enterprise uses multiple data persistence layers. They have a warehouse, maybe they've got a columnar store, maybe they've got a transactional database, a data lake. The list goes on and on and on, and that's not going away. So really, I pitched to myself was like, how potentially easy can we make this to scale? And how would we scale these data tiers, given they're all different? They all have their own different semantics around the data behavior. They all have their own different query languages. How would we approach a problem like this?
Yeah.
And the underlying thing, having sort of lived and breathed this world of solutions architecture and driving these things, is like, how do we remove that cost and complexity? It's the classic story of I'm so powerful outside of the enterprise, where I can access Google Docs, and I've got Uber, and I've got Instagram, and these highly available data-driven sites at scale that are just part of my daily life, my Netflix and what have you. And these things typically have either, huge armies of, super talented people building, supporting, and maintaining these, and they have, a huge array of underlying systems powering them. So that you get this sort of cost and complexity curve that is often unattainable for enterprises. To help scale these data systems. So that was really the challenge. Like, how can we make this simple, and potentially how easy could we make it? What really is the goal here? And that's really where Polyscale came from. It was using those specific focal points of, it's a polyglot system. It needs to be distributed across regions. and it must be easy. Like they were really the underpinnings of the design of the system, and that's really where I came up with Polyscale to be focused on taking your current data system and being able to scale that data to where it needs to be and make that as effortless as possible.
Yeah. No, it's as we were talking before the show, it's one of these concepts in which the problem is very difficult, but it's also something that people can kind of immediately see value in, right?
Right.
My users nowadays could be anywhere. I don't necessarily know where they're going to be. They don't sort of fit always well-known patterns. Depending on your business, your data could be in a lot of different places, and trying to marry that up in a way that you can deliver, great performance and cost-effective performance, becomes top of mind in a lot of cases. It determines whether people stick with your website, stick with your mobile app, whether they check out, whether they, continue streaming that game or whatever it might be. So, at its core, Polyscale is database caching as a service. Let's talk a little bit about how you go about delivering that. What happens within the service? How does an application or a database team interact with it? Walk me through some of the basics.
Yeah, and it's one of those. I talk a lot about these sort of three pillars of how the platform works, and one is to make this sort of plug and play. That was really the focus, like to make this super easy. Let's make it plug and play, and to do that, we must be wire protocol compatible with the respective databases. So, like if you're running MySQL, for example, or Postgres, the proposition of either having to replace that database or change your query language or alter anything is a hard pill to swallow, right? People spend huge amounts of time on migrating different platforms, and that's something we just wanted to avoid. So the first sort of pillar of focus was making it wire protocol compatible with those databases. So any clients you're using today, be it web apps, be it BI tools, nothing changes, and that was a huge part of what we do. So the actual onboarding experience where a dev or a DBA comes along and says, right, I need to start using Polyscale, we simply ask them to update the database host name that they're using to start routing their traffic through Polyscale rather than the client applications connecting directly to the origin database. So it's sort of a config change rather than a code change, and that's fundamental to how the platform works.
Yeah, no, that was the piece that really sort of jumped out at me was, I don't have to change anything, right? I don't have to make this work. I don't have to move to a NoSQL database. I don't have to rewrite my application as microservices. It's, it can be as simple as point things to a different direction. Obviously, when that happens, anybody who's used to doing data management, database, DBA type of work or anything, the questions start sort of coming up of like, well, if you're in the middle of things, are you secure? What am I still going to be able to see? Like how will I troubleshoot stuff? Like, walk me through the next step of, I've decided, hey, I want my application to run faster. But what's day two going to look like? What does operations look like in those types of things? How do I make sure the security folks don't freak out about, who's talking to who?
Yeah. And it's obviously top of mind for everyone. It's one thing to sort of come up with a solution and, but in production's another thing, right? It's got to be secure. It's got to be compliant. And, you've got to mitigate all risks. As, if you look at this product, the number one objection I would have as an architect observing this would be the case of, okay, you're in line with my database. So, you are not a database effectively, you're a cache, but you have to have the, you have a lot of semantics that are the same as a database. So, yeah, we really focus on, the sort of three pillars I talk about. One is that being wire protocol compatible. The second one is that we have a global set of points of presence. So similar to a CDN, we have multiple locations that actually serve the cache data. And that's key because not only can those obviously give you the fast performance, but they can also serve to meet your sort of HA requirements as well. So if, for example, let's say an entire region went down or a specific point of presence, automatically that query gets routed to the next closest point of presence. So you're effectively not going to get potentially as fast a performance as you would if it was going through the original one, but you're going to keep that uptime and availability. So we automatically sort of fail over to the closest point of presence based on any sort of failure. And also a type of failure is something we think a lot about, and that sort of goes through the architecture of the platform, whereas a Sev1 failure, a critical point of presence failure, means that I cannot instantiate a new TCP connection back to the origin database. And that's something, as I say, we mitigate by having multiple points of presence. The second sort of level of a failure would be we're not actually delivering cache data. And this is something that we've architected through the entire product, whereby we talk a lot about kind of our speed layer. And this speed layer is that connectivity from client to Polyscale, Polyscale to origin database. And then all of the caching aspects happen off of that speed layer. So outside of that layer, we decide what we want to cache, and we store that in a location that can be served from. So the complex parts of the platform that do the AI and the metrics and what to cache, that's all abstracted away from kind of that core connectivity that's actually very simple. The actual connectivity is TCP connections. So we do abstract away a lot of that complexity into a different tier of the application that can be thought of as slightly different to the a Sev1 outage as such. So yeah, the points of presence around the platform really form kind of that network of highly available environments. And then sort of finally, from a security perspective, we've got the classic sort of networking. If you want to go down the routes of sort of VPCs and peering, we can support that, and IP allow lists and all that good stuff. But really, out the box SSL, excuse me. But the fundamentals of what we're doing are quite interesting as well. If you think about Polyscale is not like a read replica. It's not taking your entire database and copying that to different locations. What it actually does is it stores the result set of a SQL query. So if I query for, get me the average salary from my salaries table, Polyscale will store that data locally to where it is requested from, so it can be used in the future. So if you think about the actual data set that we're storing, it's not like somebody can take a copy of that data and start querying it or dropping it or doing all those malicious things that can be done on a database. It's quite a different different data set.
Yeah, no, that's very, very interesting. So, you talked a little bit about points of presence. You talked about sort of where this can run and how it can scale. Walk me through a little bit. Do you often find that people sometimes would get confused as to the difference between this type of service and what a CDN does? Like where would you sort of draw the line there? Obviously, CDN is sort of pre-placement of data. You're not necessarily like owning the data per se, but so for example, is there any restriction on where your service can run? Can it run kind of anywhere the big cloud providers are located? Is there anything that would restrict that at all? And then again, maybe like kind of walk me through the difference, if this is a new concept to folks, between what you do and a CDN.
Yeah, no, and there are a lot of similarities as well. But I think the core of sort of a CDN is, the platform can run anywhere. So our points of presence network is something that's constantly growing, and our underlying architecture runs on Kubernetes. So we're sort of we can deploy anywhere, and our sort of deployment model is twofold. You can either use our kind of out-the-box SaaS application, which has points of presence everywhere, and we will just serve that wherever closest to your web application as possible. Or you could actually download and run Polyscale on-premise. So, for example, if you have SOC 2 compliance or any sort of compliance where you don't want to store your data outside of your own network, you can download the points of presence, run them inside your Kubernetes environments, and that anonymously connects back to our control plane for the cache management. So the actual storage of the data never leaves your network, and yet the management of the cache is all anonymously controlled by the Polyscale control plane. So it makes it trivial to kind of manage and implement. But you can meet those compliance requirements if you can't store your data in our network.
Okay, makes sense.
But how we differ from CDN, sort of the fundamental things, I think there's a lot of overlap. We're effectively moving that data closer to the user to solve that speed of light problem. But the other thing as well is that we also move the compute closer to the user. So if you think about the actual SQL query that executes against Polyscale's points of presence rather than going back to the origin database. So you're actually executing the queries themselves locally on the point of presence, as well as the data storage itself. But I think probably the biggest one is how we manage what data to cache and for how long.
Yep.
It's I think in a CDN environment, a lot of that data is very static. They're images, they're HTML, they're it's very easy to kind of evict that data globally when it changes, just part of my CI/CD. The data world, the data tier world is very different, where that data may be changing, it may not be changing on the underlying database. So what sort of that third pillar of the easy to use and simple to scale is AI to manage the cache. So we use AI and machine learning to derive what data should we cache, where is it cached, and for how long. And that's a big, complex part of the product that is obviously fundamentally different from most CDNs.
Yeah, that's interesting. Yeah, no, it's I think we always tell folks, audio podcasts are an audio medium. There's a ton in terms of the architecture that I think are worth diving into. We'll put some pointers in the show notes to the things that you guys have on the website that'll help folks dig into what this does, what traffic flows look like, how architecture looks like. We can definitely put all that out there. Sort of last question, I guess I want to wrap up, because I know obviously you're busy running the company and building technology. What are some of the sort of initial use cases that people are reaching out to you about, or you see them beginning to use with Polyscale?
Yeah. So, as with the CDN and as with the database, that we kind of intersect those two, we see a broad set of use cases. We really do across industries. At a high level, you can say anything that is sort of data intensive, anything where you need to scale those reads, everything that crosses regions. So let's take, for example, I think top of the list is an e-commerce site, because that's really easy to put dollar amounts against performance. So e-commerce is classic, and this type of acceleration is actually really hard to do if you're writing it manually. So if you think about an e-commerce application, there may be, let's say, 10, 15,000 unique SQL queries that are running through to that database. Which one of those do you need to cache, and for how long? And that's a really hard problem to solve without potentially months and years worth of effort. The nice thing about Polyscale is you can just plug that in and it will start inspecting that data, every single individual unique query, and building up a model to design, to work out how long we should store each one of those queries for. So that automation aspect works well on those complex web applications like e-commerce that can give you real benefits.
Yeah, excellent.
And then, as I say, we see things that anything sort of data driven. So take an airline booking website, for example. You're going to have communities that are accessing that from different countries in different time zones. There are, schedules that change frequently based on delays, and there are schedules that, they're booking out flights for the next 2 years in advance that change very slowly. So great candidates for caching. And then, we see things across just any type of homegrown application, like online booking, for example, where, again, caching is hard because, you don't want to be serving people stale data. Are those events available? Can I sell those now, or are they taken? So there's complex parts of that, how you evict that data that we're good at.
Interesting.
And, the sort of the blunt assertion to the market is, if you said to any developer nowadays, you're building a new web application or a new website, I think it's very unlikely that you would put that live without integrating into a CDN. Why wouldn't you pay a few dollars a month to plug in Fastly or Cloudflare or any of these amazing companies to make your data fast everywhere. Like, why would you not do that? And that's really the same assertion for Polyscale, is that if you're running a database, why would you not accelerate your reads everywhere? Because it is literally that effortless process to click and connect. So yeah, we're really focused on sort of the broad set of use cases, but for anything data intensive and specifically e-commerce is really top of the list at the moment.
Okay. Yeah, no, it makes sense. And, it's good that there's, again, sort of those immediate types of use cases that can plug into this. Ben, I want to thank you for the time. This has been, like I mentioned, it's always fun for us to dig into not only sort of new technologies, but very much new companies that are out there, out there changing paradigms and trying new things. What's the best way if folks, are listening to this, they're interested in talking to you, talking to your team? What's the best way to get engaged with the folks at Polyscale?
Yeah, I mean, the best way is to hit the website, polyscale.ai, and there you can join the community Slack. There's IM built into the site as well. You can email us. We're doing regular webinars and events, so feel free to join those. And we'd love to engage with anyone who's curious about scaling their data tier.
Excellent. Good stuff. Well, folks, with that, I'm going to wrap it up. We want to thank Ben for educating us today, for introducing us to some new things that we're always excited about learning about. And on behalf of Aaron and I want to thank Ben. I want to thank all of you for listening. Thanks everybody for telling a friend, for helping us to grow the show. And we are, by the time you listen to this, we're going to hit another very, very big milestone that will get revealed here pretty soon. But thanks everybody for listening, and we'll talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.